Hello everyone. Today I'm going to talk about a basic concept in mathematics. It is called place of value. Place of value. I'm sure you have heard of it since primary school, right? So given a number, say number 12, right? So you know that this is a number that represent 12. So it's 12. So it's basically 12 is obviously larger than 10. All right. Now, if you don't know this arrangement, you may wonder. So if you ask you, so you got because obviously this 12 is constructed by two numbers, namely 1 and 2, right? Now, from our early knowledge is that, since you are very young, that you know that 2 is certainly larger than 1, okay? So does that mean if you apply these common sense, to these particular issues, can we say that the number 1 here is smaller than these 2? Of course, immediately you will find this is not the case. Because when we put a number in this way, we actually have assumed that we have actually placed these two numbers into different places. All right? The first place, where on the right hand side, actually represent the unit, a place called a unit. The second place called 10. Okay. And of course, this kind of the architecture go on continuously, almost forever. So you can actually imagine that the third place is actually called 100. Of course, if you can account coin or money, then you should be able to realize that this very first place represent 1 cent, and the second place will represent 10 cents. So one number here actually represent 10, and the number on the other hand, by way of contrast, the number 2 here actually represent 1. So if you write a number in this form, then the value represented by 1 actually is larger than the value represented by 2. So in this case, we can argue that if you put a number in the second place, then the value represented is larger than the one which is located in the unit place. So in general, can we draw boxes to represent this concept? So perhaps I use different color to indicate that this is these boxes are generally invisible. So what we do, we just we put a box here, and then we just continue to draw this box here, or you can copy that box. If I just repeat and draw that one. I want to probably say 4 boxes on the left hand side of the decimal point. Okay, I will just draw another few boxes, say perhaps 3 or 4. Oops, size should be the same size, but doesn't matter. It's just for illustration purposes. Okay. Now, these boxes is called place, or a place where you put the numbers. Okay. How many numbers can we put in this place, in each place? Can you imagine? Yes, the answer is you only have 10 choice. So you only have 10 choice. Let's go to here, just go to read one. So pick up the color. So we pick up the, if you pick up the pen, because I go back to this a little bit more. So we use the colors 1. So each box is another important thing is called a decimal point. I'm going to a decimal point here. It's called decimal point. They call the decimal point. So it's called a decimal point. Decimal point is used to separate the larger boxes, if you want to say larger boxes with larger value, and boxes with relatively small values, okay, roughly speaking. But to be exact, just repeat that one. The first box on the left-hand side, actually the value, your unit, is actually 1 or unit. The one next to on the left-hand side will be 10, okay. And the third one, the third boxes or third place is actually 100. Okay. Okay. By the way, do you know another way to write these large numbers, right? So one way is to, the common way is to use this power form. If I say put the 3 here, so actually the 10 to the power of 3 actually represent 1000. So each number in these boxes actually represent 1000. Now if you put the proper name, say 2000. It's 20, 20, 19. We just put this phone number here. So what can we read? So in order to read that, so the 2 here actually represent 2000. Okay. And the 0, of course, in this case means there's no value. So no value in this place, no value in this place. And this one, the 1 actually represents 10. So if you put them together, you will argue the correct way to describe is that the 1, or the 1, or the 1 is of course the 1 is smaller than 9 if in isolation. But if you put into the places of numbers, it's called places of numbers, or place where you can put numbers. It actually represents 1 more than the 9 in the unit on its right-hand side. Similarly, the value of the place keep decrease. Every box increased by 10 times. So this place represent 1/10. So any number you see here will be represent 1/10. So even you got to say you got like 8 here, then you still supposed to say if you put a number, say if this is 8 and this is a 9, okay. So you may ask us, oh, we got 9. So in isolation, 9 is certainly 1 unit larger than 8. But if you have put into this particular design the boxes, which is it's convention for human for over 1,000 years. So that is where we represent the number of either is too very big or very small. Now we just continue this notation. So the value, can you guess that? For the second box or second place after decimal will be 1 divided by 100. So it's very small. So it's 1 part in 100. The third one is even smaller. Say that would be 1 divided by 1000. Okay, let's invent something that can we use our notation here? We can write 1000 instead of too many 0. We just put the 10 and use index here, or exponent, what we call exponent here. It all represents the same thing. So 1 divided 1000. Now, if you have learned the negative power, so the alternative you can denote these values by using this negative power. So that negative power is 4. Okay, so after you can spend some time to review how can we represent the 10,000 or 10,000 in this way. That's another lesson. So just return to our notation. So if you just put any number here, say this is a 3, this is a 5, for example, right? So obviously, the value this number represent are different. So that is a very important concept for people to learn mathematics. So of course, normally we take this for granted that we don't have to draw these boxes, and we just assume that everyone accept and understand this convention of notation of big numbers. Okay, let's take some example to illustrate how important to understand the place of value. So if I just go to the one example, say if you were asked to do the subtraction of the two numbers, say you have 2.9, 2.8. Let's change something else. We change something. You say 2.1 and 5. Okay, minus 1.4 and 3. Okay, we just make the hypothetical question so that what is answer? What is answer to that? Of course, we know that this is just simply to put these two numbers together, properly together. So here actually, we know that to do that, then we just put the first number here. I'm writing larger in order to illustrate some other issues here. So we basically say there's a 2.15 minus, be careful. So here we have put the decimal number in the right place. So if you're not too sure, if you're still not too sure, you can put the decimal number together first, and then write the numbers to be take away from the first number. So that's how you have to make sure that the place, so the reason we get alignment, it is very important that these place, so the unit number, the unit place must be put in the right place. Okay, or if I just draw the box here, so if you still don't understand what I'm talking about, then you have to make sure that if you have two numbers, right, when you do subtraction, you have to make alignment. Okay, the number will be written in this way so that each place must be vertically in a. If you put them together, they must represent the same place of value. Okay. Okay, let's do this subtraction. It's simple that we know that we do from the right hand side. So 5 minus 3 will be equal to 2, right? However, here we got trouble. 1 minus 4 we cannot get a positive. All right? If we do want to get the positive number in each place, okay, we have to see, put it, or then return to that definition. When you put a number into the place, you have to choose a positive number. Okay. So in this case, we have a shortage of numbers. So what we can do, and in this case, we can borrow. So can use different color to highlight this operation. We can borrow something. So we can borrow the money from the our neighbors. Okay, our neighbor on the who lives on the left-hand side, because then he got obvious surplus. So you got 2 here. So you say, why don't we bought 1 unit from you? I'll say, if you agree, yes, of course you can. And then you will replace this value. Be careful. You will place this value into your place. But in this case, you must understand the value, just 1 unit value from the boxes, from place on your left-hand side, actually represent 10 units in your present place. Okay, so that's why when you finish saying, okay, we got 11 already, so the 10 minus 4 plus 1, that would be equal to 7. Okay, and if you drop the decimal number, can you see that's in alignment? So very important to put the decimal number in alignment, in the same position. And because you have borrowed 1 unit from this one, of course, just as probably above, you have borrowed 10 cents or $10, or depending on the unit you choose. So basically, this has become 1. So 1 minus 1, you got 0. Okay? So that is how to do this subtraction by using knowledge of the place of value. Interestingly enough, I noticed that students are doing this problem solving using slightly, I would say, incorrect method. Okay, same problem, so we just write 2.15, right? So I just this actually come from the real case. A student had been perform a subtraction. Okay. So what he did rather, is that the first step is all right. Okay, to highlight his message. The first one is he knows that he will subtraction must make alignment first. Yes, that's correct. And then he do the subtraction. So first is doing the subtraction from very right hand side. So 5 minus 3 will equal to 2. Yes, correct. Then he said, oh yes, we have trouble that we need more, because otherwise this number is smaller than this one, we got negative. Okay, it is not allowed. It is not allowed to put a negative number in the place when you build the numbers. Okay, so what can we do? Well, what can we do is we can borrow. He said, oh, need to borrow something, but be careful what he did. So he said, oh, why don't we borrow money from this side? It's alternative. You see, we are our neighbors. You see, this neighbor got 5. The one on my left only got 2. Why don't we borrow some from someone is richer? Okay, so we just, he's probably have more money left, so we can borrow something from there. So you say, well, but here he had made a terrible mistake. When you borrow 1 unit from the place on his right-hand side, he assumes that the value will be representative 10 in this place. Okay, so what he did, the same thing. So this is, okay, I just assume, say, I can borrow the money from either side. So I borrow from the one which have, seemingly a large value. So he borrowed one from here, and he just take a notation here. And then you say, well, 10 minus 4 plus 1 equal to 7. Yes, that's correct. Okay, you say, oh, the rest is correct. Say, okay, decimal point position. And this time I say, oh, because there's no one borrowed from these particular numbers from this particular place. So he got his result is 1.72. Of course, something was terribly wrong. Why? Because return to this notation here, because the value he borrowed from the behind, or from behind, or from his from the place on his right, is actually represent just 1/10. Okay, so you can only borrow, say, 1/10, or in other words, just 0.1. Okay, instead of 10. So this is a terrible mistake. So never borrow 10 from the box behind you, okay, or on your left-hand side. All right. So let's return to this definition. So if you have, so that is how the concept place of value is defined and applied in the mathematics